Awesome. Well, I think that's enough time to give a couple of late arrivals to join the webinar. So I think we'll get started. Perfect. Well, welcome to today's webinar on printing biodegradable PCBs. Excited to have you all here. Thanks for all the folks who have answered our first poll just around whether this being your first Voltera webinar. I'm going to end that one now. But yeah, great to see a lot of new faces here today. So for today, we have yeah, I'll just go over what we're going to cover today. So I'm going to start off by just chatting about sustainability with the V1 and how you can reduce your footprint during the prototyping phase of yeah, developing your products. And then we are very excited to have Jack Herring here today from Jiva Materials to talk about Soluboard. So yeah, Jack's going to share a bit about it. It's basically the world's first fully recyclable PCB substrate. I got a glimpse at his presentation yesterday, and there's yeah a lot of interesting stuff. So you guys are in for a treat today. Yeah, and then once Jack's finished up with his presentation, we're going to jump back over to me and just going to show you guys how easy it is to integrate Soluboard into the V1 workflow. We won't be doing a demo today, but yeah, we will just kind of go through the workflow as it is. And then throughout the presentation, if you have any questions, please use the Q&A feature in Zoom. We've got a couple of folks from Voltera who can answer those quick questions that you might have that are easy to answer. But yeah, anything specific to Soluboard or integrating into the V1, we'll try and save for Q&A at the end so that we can answer them kind of live on the floor for you. So Jack and I will be able to field those questions. Yeah, and that's kind of the plan for today. So I'm just going to run one more quick poll here for you folks, and then I'll just jump into my presentation. So we'll keep that running while I'm going through the first section here. Perfect. So sustainability with the V1. So prototyping PCBs traditionally relies heavily on a lot of subtractive manufacturing methods. Um, PCB Way, if you've been to their website, they actually have a really great interactive overview of each of the stages of the process. Is really cool to check out. I highly recommend going to see what's all involved in building a PCB. But especially during the prototyping phase, this can be really waste heavy. And there's a growing need for more sustainable practices, especially in R&D and in manufacturing for prototyping. And this is where additive manufacturing can play a part. Perfect. So additive manufacturing, typically thought of as 3D printing, has gained a lot of attention in recent years. Methods like FDM, SLA, SLS printing have become kind of household names or common terms in the industry and have been regularly used to bring 3D ideas and concepts to light. So for prototyping physical models and hardware components, this is kind of the go-to methodology now. And for Voltera and prototyping electronics, direct write printing is the additive manufacturing method that we kind of utilize. So some of the benefits to additive prototyping. Um, there's a lot of them when it comes to sustainability. One of the main ones is you only need to deposit the material that you plan on using. So low waste when it comes to actually building your boards or prototyping. It allows for quick revisions. And one of the benefits to that is you don't need to worry about new tooling for each of those revisions or having to hit a minimum order quantity. So you don't have to worry about bulk orders. You can kind of just produce the volumes that you need. Um, Additive also reduces your reliance on supply chains. We saw recently over the COVID pandemic, supply chains really got bogged down and were limited. But even at the best of times, relying on supply chains can be a very time-consuming process with shipping lead times and overall just the packaging waste that is involved with having to order multiple iterations from an offshore supplier. One of the other benefits is it promotes efficient design and workflows. Oftentimes, you're able to rework a board a little bit more easily, or yeah, if you do make a mistake on your first kind of pass. With a lot of additive methods, you're able to kind of wipe clean and start fresh. So you can have fewer discarded prototypes as well. And we mentioned a little bit earlier on, just with the traditional PCB etching process, there's yeah, a lot of kind of hazardous waste that's a byproduct of that. So in the prototyping phase, we can eliminate a lot of that by relying on more additive methods. And one of the great benefits is more substrate options because we're avoiding some of those corrosive or high heat or high pressure processes. It opens up what we're able to utilize as a substrate. So looking at the V1, at its core, the V1 is a 3D printer, but for conductive inks and serves as a great example of additive prototyping. It ticks a lot of the boxes we mentioned earlier on. So you're able to dispense on the material that you need to work with, and you can dispense only where you need it. So a lot of material savings there and time savings. Again, this is one machine for the whole process. So saving some room on your desktop, but yeah, we're able to print, cure, reflow, drill through holes, components, vias, etc., all in one package. So yeah, really a time saver there, and you're able to get a working prototype in an afternoon, which really unlocks your ability to iterate faster on your designs. So with additive, one of the other things I mentioned is the ability to use uh, more substrate options. And because of that, we're able to rely or lean on more sustainable materials as well. And this is because, again, we're able to directly dispense onto these substrates without it needing to withstand harsh chemicals, high heat, high pressure processes. So yeah, we're really able to lean more into the sustainability side of what we're printing on. So yeah, we're able to look at more bio-based or recyclable options, which I think is a great segue to Jack. So Jack's from Jiva Materials. He's here to talk about Soluboard today. And yeah, he's got a great presentation, and it's leaning all into the recyclability and what our PCB manufacturing could look like in the future. So Jack, yeah, I'll hand it over to you.
Thanks, Nathan. Hi, everyone. I'll just share my screen. Okay, is that visible to everyone? Is that good, Nathan? Yep.
Yeah, looks great.
Okay, perfect. Okay, hi, everyone. Thanks for your time and looking forward to having a discussion later on. But before that, I can give you a brief run through of Soluboard. For those of you that don't know, I'm Jack Herring. I'm the founder of Jiva, and we're the creators of Soluboard, which is the world's first recyclable and biodegradable PCB laminates. So today I'm going to walk you through exactly what Soluboard is, how it's reshaping the way we think about sustainability, and how we help tackling problems such as e-waste. So our mission is to tackle e-waste using naturally derived materials. So we're reducing carbon emissions and also offering an alternative end-of-life solution. So we're based in the UK, in Hampshire, and we've been developing sustainable alternatives to incumbent PCB laminates since 2017. So I actually invented the material at university. I was given a brief by my design tutor to choose a waste stream to try and optimize. So I selected e-waste, which is the fastest growing waste stream in the world. So um, our product, Soluboard, is a biodegradable thermoplastic laminate that is able to disrupt the traditional use of epoxy fiberglass PCBs, such as PCB laminates, such as FR4. And not only do we reduce the carbon footprint by over 68%, we're also enabling recovery of precious metals in a much more optimized way, supporting a truly circular electronics economy. As I mentioned, I'm the founder. The journey began back in 2017. I've been working very closely with Steve Driver since 2019, who's our CEO. He's previously commercialized other products, having built PCB manufacturing businesses, leading them to $20 million plus revenues. And we now have a team. This is just a very small selection of our team, but we have experience in material science, manufacturing and electronics, sustainability and certification. We also have a very strong advisory board along the bottom there. So you can see we're also working with people like Alan Morgan, who's very influential in the industry. He's the president of the European Institute for the PCB community, and he's also a technology ambassador for Ventec International, which is a global leading supplier of materials and equipment for the PCB industry. So I'm sure everyone in this webinar is aware, but PCBs are the hidden infrastructure of our electronics, and they're the backbone of everything that we own now. But they do come at a significant environmental cost. By 2030, we're projected to actually be generating over 6.5 million tons of waste PCBs every year. And sometimes, particularly in lower value applications or shorter lifespan applications, once the existing PCBs are discarded at end of life, they are very difficult to recycle, and can often be sent to landfill, or in a best case scenario, they are incinerated at end of life to recover any value that is in there. So this e-waste crisis is accelerating, and we're expected to reach 82 million tons of e-waste by 2030. We're also facing big, very strong regulatory pressures, such as the European Scope 3 directive, which is demanding full transparency and carbon accountability from electronics OEMs. And the electronics industry is urgently in need of a better alternative. We believe that we have the solution to that. So this is where Soluboard comes in. So Soluboard, which we use to produce our PCBs or recyclable PCBs, is a revolutionary alternative to the likes of the conventional materials made using epoxy and fiberglass. So we have a minimum of a 68% lower carbon footprint. And this is also a drop-in replacement for the likes of FR4 and other rigid PCB laminates. So we're able to integrate it relatively seamlessly into existing PCB fabrication processes. We're also able to offer a potential alternative end-of-life solution without the need for harsh chemicals. So as the name suggests, our Soluboard PCBs can potentially be recycled through a certified non-hazardous hot water-based process, depending on the complexity of the board. But our USP really is our carbon footprint reduction. So not only do we offer an efficient recovery of precious metals, but we're also working towards that circular economy more in electronics. So this is just a brief overview of our journey so far. I invented a material at university. I don't have an electronics background, but I was aware of what an Arduino was, so I wanted to take this material that I invented and validate it with an Arduino design. So on the left-hand side there, you can see a very early version of the material, which was originally designed for printed electronics applications. Across time, we've moved more towards copper-clad materials, but we are still compatible with printed electronics, as you will see. And we can now fabricate through standard manufacturing processes, plated through whole two-layer PCBs with multi-layer technology on our roadmap. So our growing portfolio supports both additive and subtractive technologies, as I mentioned, and this means that our material can be used in a variety of different use cases, whether that's rapid prototyping or standard production lines. We have a variety of different materials available using different natural fibers, such as jute and flax, but we are exploring other alternatives at the moment. So we are aware that anyone who designs PCBs has a huge variety of different materials that they can choose from when they're specifying or designing a PCB. So If you're looking for something which is very versatile, FR4 is the obvious choice, but there are lower costs, flexible alternatives, or if signal integrity is important, you might look at PTFE, for example. Heat dissipation, aluminium, or is becoming very popular. But we believe that we're the only material which is offering the reduced carbon levels at a validated level, and also a validated and certified alternative end-of-life solution. So as I mentioned, our USP really is our carbon footprint, but for certain PCB designs, like this single layer PCB for the lighting industry that you can see here, our boards can be dissolved in hot water, so at 90 degrees Celsius for 90 minutes or so. The copper and the electronic components can be removed and recycled in a much more concentrated waste stream, and the natural fibers can be composted within 75 days. The wastewater that is produced as a result of this recycling process is also certified as non-hazardous. Um, and this means that the wastewater can be discharged to standard effluent treatment plants for any removal of any remaining waste solids. And we're currently working on validating the solid waste stream as being non-hazardous as well, but we don't expect any issues there. So the way we manufacture our material is different as well to the likes of FR4. So FR4 is a thermoset which is produced using epoxy resin. This means that there's typically quite a higher carbon footprint associated with the likes of what we call a wet process. So we are using a dry process. So we're actually using a polymer blend, a powder. So we have our polymer with our flame retardant, which is used to impregnate our natural fibers under heat and pressure. We can then potentially apply copper foil for that intended output product, but we're also able to stop that part of our manufacturing process and just produce bare Soluboard as well for printed electronics applications. So here you can see a brief overview of our carbon footprint. So when we're comparing to FR4, we are able to offer um, between a 68 and a 73% carbon footprint reduction, depending on the thickness of the material. So these calculations here are for a standard 1.6 millimeter material. These numbers take into consideration materials, the processing and the transports. You might notice that there's no recycling in there. So with these numbers, we're actually just comparing like for like Soluboard rigid laminate against FR4 rigid laminate. Um, so here we can see that we actually have a more significant carbon reduction for a 0.4 millimeter material as well. So we also are able to benefit from downstream um, benefits of using our material. So as we are a thermoplastic, we do encourage users of our technology to use low temperature soldering. So we're actually able to reduce oven energy use by 40% by switching from 265 degrees Celsius reflow to 170. And this allows manufacturers to save nearly 60 tons of CO2 every year per oven. Associated with that CO2 saving is also cost savings as well. So this would equate to about $9,000 per oven every year just by lowering your reflow temperature by 100 degrees. So we have to look at the impact of this technology in several use cases. So one market segment where we're seeing a lot of traction very recently is in IT peripherals and computing. So PCBs actually account for 68% of a laptop's carbon footprints. And we've done the calculations, and by switching out 3.5 million Soluboard trackpad PCBs, we would actually reduce the carbon footprint of a user by 1.57 million kilograms of CO2. This sounds like a lot, but this is actually just 10% of the actual units produced by one laptop manufacturer that we're working with. So we're certified to ISO 9001 quality management because we don't want any users of our material having to compromise on the quality of their final products. So we've developed relationships internationally off the back of our IP. So we have patents in the UK, US, India, Japan, Taiwan, and many more as well. And we're looking to develop our supply chain in North America as well as Asia in the coming months, as we've been quite heavily focused in Europe up until now due to most of the regulatory pressure coming from that part of the world. So we believe that our material is the most mature offering at the market at the moment on the market. But there are other challenges out there. So for example, if we look at Recyclad, which is made by a Chinese company called Chengyi, this is an FR4 variant with a degradable hardener. This does mean that a harsh solvent is used to do any recycling at end of life. So there's only a 23% carbon reduction compared to our approximate 70%. If we also look at paper shell, they're using a paper-based material. This is a relatively low technology readiness level compared to ours, and they have yet to validate any life cycle assessment. But we don't want to be too negative about any competitors out there because they do validate that there is a need and a demand for a solution in the market. And we're all trying to solve the same problem at the end of the day. So technically, Soluboard does hold up. We are 37% lighter than FR4. We also have strong thermal and electrical properties compared to the likes of FR4. We tend to sit somewhere in between the likes of SEM1 and FR4 in terms of our properties electrically. Um, so one of those, for example, is our CTE, our coefficient of thermal expansion. This is slightly lower than FR4, which does allow us to have more dimensional stability, which I'll expand on. And we're also now UL recognized, and I can expand on a few of these tests here. So this test at the top, the ball pressure test, this one is something which not everyone is familiar with in a laminate world. So again, because we're a thermoplastic, this is a unique test which is used for thermoplastic materials used in electronics. So it took us a very long time to pass this test because there's a 5 millimeter steel ball which is applied under a force of 20 newtons at 125 degrees Celsius for 20 minutes. So this is quite a strong force at quite a high temperature for a thermoplastic material. On the right hand side, you can see that this was a failure. This was something which we had to deal with for a number of months, but we're now consistently passing this test every time, and we don't have any impressions above the 2 millimeter, which is the pass rate. In terms of flame retardancy, we currently sit at a V1. For those familiar with the test, it's all about the amount of time that it burns. Um, Unfortunately, we were 1 second away from reaching the V0 rating, which is what the incumbent market leader, the FR4, is. But we're now also achieving regular V0 results, and we will be resubmitting to get that certification as well. So just looking at the CTE that I mentioned previously here. So we've done some benchmarking against three random FR4 samples from different suppliers. And typically FR4 has a TG, a glass transition point of about 130 to 150 degrees C. And this means that they do tend to have a sharper increase of this around this TG when measuring the CTE compared to our material. So this does mean that because we have a lower CTE, our expansion and contraction is less dramatic compared to FR4. So a lot of the time with the high temperatures of standard reflow ovens, you can see that there might be stress put on plated barrels and solder joints, but this lower CTE in our material reduces the likelihood of any of these failures due to cracking, delamination, warping, etc. So this is something which we are now exploring a bit further, and some of our customers are are very interested in. So we also had the benefit of working with the University of Portsmouth here in the UK. They have a CT analysis machine, which is very important for us, so we can look at the impregnation and analyze any potential voiding that may occur during the impregnation process. As you can see here, we have uh, no voids. We're able to demonstrate that we have good consolidation and impregnation for both the raw material as well as the Soluboard PCB. So drilling, this is something which we've had to slightly tweak during the manufacturing process. So we have slightly brought the speed down of anything that we have to drill on our material because of the thermoplastic properties. But you're able to see here that we do achieve nice plated through holes. Um, we have nice barrels there. You can see we have consistent impregnation of our natural fibers. Environmentally, one question that we're always, it's a valid question. One question that we're always asked is about our resistance to humidity and our reliability. So we do tend to have a slightly higher moisture absorption, so a higher weight gain percentage than the likes of FR4. And the typical environmental and reliability test is 85 degrees Celsius, 85% relative humidity for 1,000 hours. So we've actually found that by decreasing the RH by 10%, this has a significant improvement in terms of the moisture absorption of our material. And this reduction doesn't actually have any negative repercussions for the users of our material. Um, so we have also been able to demonstrate that our two-layer PTH PCBs are even less subjective to the humid environments that they might be in because of the reduced surface area. And we have multiple OEMs now who've put our material through these reliability tests, and they have passed consistently. So our datasheet and design guidelines are publicly available. I'll include them in this presentation, which will be shared after the webinar. So please take a look for the designers out there. But we're also able to benefit from aligned partners with our technology. So Lilotree is a US based company. They're actually offering a nickel-less ENIG process. So this is a gold surface finish. So for when those of you have a when you have a chance to look at our design guidelines, you might notice that we don't have standard gold finishing listed. This is because of the high temperature and harsh processing of the nickel application process of this standard finishing, which is the step before the gold is applied. So Lilotree has actually removed that step of the process. Um, that's great for us in terms of being able to offer this finishing to our users. But we're also able to reduce the cost for them. We're able to reduce the amount of gold which is actually applied to the material, and it's cyanide free and ROSH compliant. So we've already demonstrated that our material is solderable using this technology. And we're also exploring the potential synergies in terms of the circular economy with Lilotree. We've had discussions about potentially Lilotree recovering our waste PCBs at end of life, removing the gold from our boards in a much cleaner and more efficient manner than the likes of an FR4 board, and then they can reuse this gold as their feedstock. So we're always looking ahead to how we can improve our product. So next up, we are looking at thinner cores. So thinner cores are going to allow us to branch into the multi-layer market. So we're looking at different grams per square meters, different natural fibers. So we've worked with flax before, but we're also looking at the likes of hemp and lyocell, which is a more engineered cellulose-based material. So we're also looking at our potential improvements for our production, so our continuous production. So at the moment, our material is produced into prepreg, which we then consolidate into copper-clad laminates as a second stage of the process. What we would like to do moving forward is have this as one continuous process, which would actually be able to reduce our carbon footprint even further. So we would expect that we could achieve a 76% carbon reduction through this continuous belt manufacturing process. So Soluboard is the most mature challenger to the incumbent materials. We offer reduced carbon footprints, we are fully recyclable without any harsh chemicals, and we can maintain the performance which are demanded by the OEMs that we're working with. But we believe that a sustainable choice should not only meet the carbon mandates, but also provide a transparent supply chain, which we do, right from raw materials through to finished products. So if you're a designer, an OEM, or investor looking to lead in circular electronics, we're happy to work with you and happy to take any questions. Thank you.
Awesome. Thanks so much, Jack. Looks like there's a ton of questions that have been asked throughout your presentation. So we'll get to those in just a minute. I'm just going to share
Okay.
my screen again here. And while I'm sharing, I'm going to launch another poll for the folks in the audience. But yeah, lots of great questions for you. We'll be able to dive deeper into those. Before we do, I'm just going to quickly chat about using Soluboard on the V1. Yeah, I think Jack, in your presentation, you really highlighted really well how yeah, Soluboard can just be a drop-in substitute for FR in large scale production. But yeah, this is kind of this part of my presentation is showing just how easy it is as a drop-in solution to use for prototyping on the V1 as well. So yeah, like I just mentioned, using Soluboard in the V1 workflow is a direct swap for FR4 boards that we typically use. It's well suited for the heat requirements of our bake and reflow steps. So for us, the workflow is largely unchanged. So yeah, this is kind of how it looks. So first you load in your circuit, then you clamp down your Soluboard to your V1. Position your circuit, and we use touch probing to get a height map. Then we calibrate our ink, we dispense our design, and bake. So quite simple. Each of these steps just takes a couple of minutes, and we're able to get a prototype rolling pretty quickly. Great. And so two-sided boards. Soluboard works really well for two-sided boards in our applications as well. Our V1 drill had no trouble drilling through for through-hole components and vias, and Soluboard held up really well to our rivet pressing to create that secure connection to the two sides of the boards. And yeah, it's able to withstand the heat from our hand soldering as well, since we already use low temperature solder for all of our applications, as it works really well with printed electronics. So yeah, for us, this has been a really great alternative to FR boards for prototyping boards. It just works. It's plug and play, which is really awesome. So we're happy to say that we're stocking Soluboard in a limited supply right now, but we want to get some users hands-on with it and giving us feedback on how it works for their projects. So we're carrying packs of Soluboard as of right now. So you can go to store.voltera.io and grab some of those and get hands-on and get using them. Yeah, so I'm going to invite folks to keep the questions coming. We're going to move into the Q&A right now. So I just ended the previous poll. But yeah, opening up kind of the floor in the QA. Yeah, so I think, Jack, most of these are for you. So I'm just going to start
Great.
hitting you with them if that works for you.
Yeah, no worries. Let's go.
Perfect. Great. So just kind of a couple quick ones. What is the biodegradable duration? I know you touched on this in your presentation, so just a nice light one to get you started off with.
Um, if the question's referring to the time that it takes to biodegrade. In the natural environments, our testing suggests around 75 days for the actual natural fibers itself after the recycling process. Um, if you leave a fully assembled board just to biodegrade, then it will obviously take longer. That's not something we have particularly investigated yet because we would always encourage our waste stream to be recycled. But yeah, in terms of the natural fibers post recycling, around 2.5 months just left on the topsoil outside. That's the worst case scenario.
Yeah, awesome. What via sizes can you achieve? Are there plans for multi-layer, blind and buried vias, etc.? Any timelines on those?
Yes, so multi-layer is on our technical roadmap. We're hoping to have a proof of concept between Q3, Q4 this year, but we're still optimizing the thickness of our material. So we've been able to get down from where we started at 1.6 millimeters down to 0.3, 0.4 millimeters now. In terms of the vias, we can share the technical data sheets and the design guidelines, but our minimum hole diameter at the moment is about 0.3 millimeters. That's something which we are constantly trying to reduce as well. Buried and blind vias that would come in partnership with the multi-layer technology that we're developing as well. But I'm aware that's another technology step altogether. So we would first start with the 4, 6 layer PCBs and then eventually look to move up from there.
Yeah, that's really great. Exciting stuff to come for sure.
We hope
Uh,
so, yeah.
yeah, yeah. Perfect. I had a couple of these tagged for answer live. Yeah, can any PCB shop obtain Soluboard, or is it only processed by yourselves currently?
So currently, our business model has been to engage with an OEM or a manufacturer of an end product who are then able to influence a PCB shop to use our material or specify it on their bill of materials. If there is a PCB shop out there who has customers that are actually interested in using our technology, then we're always happy to work with them, and we could look at getting you approved as being a provider of our Soluboard PCBs at end of life. That's definitely something that we'd be interested at looking at. But as we've gone through this journey, we found that it's usually the OEMs and the end customer who has the influence and the power in terms of saying, I want you to swap out FR4 for this material.
Yeah, absolutely. Um, so this one's from Petter. Hello, Jack. Can you share the specific polymer you use in the blend? I suppose PVA or similar, soluble in water. Thank you.
Yes, so we use polyvinyl alcohol. Um, so we are looking at improving this in terms of the overall impact of such a raw material. We're identifying potential use cases for more bio-based materials further down the line. But it's a material which is used heavily in various different markets, and it's been validated as having minimal environmental impact. So that's something I'm happy to share because it's in our patent, and our patent is published globally now.
Yeah. That's the fun part about getting things patented is
Yeah.
you finally get to share the hard work you've done
Hmm.
and all the neat tricks. Yeah, so this one's from W. Bell. Can you expand on the statement about lower surface area resulting in less absorption? I think this was referring to the moisture absorption. Surely like for like circuit has the same surface area. I don't quite understand.
So I was actually referring in comparison to a single layer board or a non-plated through-hole board. So with the plated through holes, you have a barrier against any moisture going through the board, so the two layers are effectively stitched together. So I was referring to how a two-layer plated through-hole board would be able to be recyclable in comparison to a single-layer non-plated through-hole board. There's less access points for the moisture or the hot water to get into the material to engage that dissolving process. So apologies for any confusion, but that's what I was referring to.
Absolutely. Yeah. Um, got one from Nahesh. Sintering technology using silver and copper is gaining more traction in power and electronics. What plans did Jiva and Soluboard have there?
Yes, yeah, we're aware of sintering. It's not something we've looked at particularly closely right now. Obviously, with our thermal limitations, it's something we would have to be aware of, and we might have to do some tweaks there in terms of the makeup of our material to withstand that. But it's something that we would be interested in trialing if that's a part of anyone's developmental journey. If that's a process that you're looking to move towards, then we're happy to engage in some testing to see how our material performs.
Awesome. Um, this one's from Ragav. Do you have any plans for integrating your material with rigid flex PCB? Can you provide more information about the signal integrity or dielectric constant capacity with your biomaterial? If those last two are just in the data sheet, I'm good with it's in the data sheet answer too.
Yeah, yeah, I would use that answer for the dielectric constant. It does vary depending on the version of the material you're looking at. So depending on the weave of the natural fibers, for example. But we do tend to sit between the 3.5, 4 dielectric constant point. Um, Sorry, I forgot the first part of that question.
Yeah, the first part is just any plans for integrating into kind of rigid flex PCBs.
Okay. Um, yeah, it's something which has been asked of us previously. Our material is naturally more flexible um, than the likes of FR4 because it's a thermoplastic. So our material is inherently more flexible, so we could see some synergies there. It's not something that we've explored particularly at the moment. We're not sure if a truly flexible board would be on our roadmap too soon. We're focused on the multi-layer applications right now. But there could be some projects there for us further down the line.
Cool. Very cool. A question just about assembled PCBs. The question is, are there any kind of PCBs end-to-end product available to purchase and just experiment to see just what the product's like?
Um, yes, so I mean we do have samples we can send. We have test coupons, test vehicles. Um, Typically, we do encourage people to trial it with a specific application or PCB design in mind. That way, you can produce a like-for-like FR4 version, for example, and do some accurate benchmarking. But yeah, that's something that we do. We've been doing that actively. We're always happy to produce samples and issue samples to people. We typically have a few weeks lead time because we're not currently at scale in terms of our PCB production. We're focused on the laminates.
Yeah,
But yeah, that's something that we're happy to work with people on if they have a specific design that they're looking at.
yeah, awesome. Timothy asks, what about for immersion cooling solutions?
Uh, I'm not sure what's the context of that. How would you
Yeah,
interpret it,
yeah,
Nathan?
yeah. I'm not sure either. Just yeah, I guess there might be some requirements there. So yeah, I
I
guess I would
mean, if you're
encourage.
looking at potentially using it in server applications, which are called using immersive liquid solutions, then we have trialed our material being immersed in other solvents other than water, and we were actually able to survive them. So it all depends on the solution, really.
Yeah, I think that probably is the yeah where they're headed with that question.
Mm.
Um, Perfect. Got questions coming in and they're jumping on me, so trying to read them. Um, is it possible to make a simple Arduino with soluble PCBs of yours and then flex them into the shape that we want?
Ooh, that's interesting. It would have to be a relatively thin version of our material. It depends. I mean, I think in that case, it would be the bigger issue really would be the circuitry and traces and the components and ensuring that they remain
Yeah,
mounted. But that's a particularly niche question. So that's a project I'd be happy to engage with you on, and we can help answer that more accurately.
yeah. It seems like a good kind of bridge to some sort of in-mold electronics or something that needs to conform to a specific shape. So, yeah, it could be
Mm.
interesting for sure. I think we did have a question just about, and you did touch on this, so I'm just going to try and tick it off for us. But just stating again what the thinnest size you're currently able to make. How thin
So
can the
we've got,
substrate be? Yeah, yeah.
yeah, about zero point 0.3. Sorry, was it thickness or via?
Yeah, how thin can the substrate be
How
made?
thin?
Yeah, yeah.
So yeah, we've recently just produced a zero point 0.3 millimeter material. So we're looking on improving that all the time. But because we are using natural fibers as the reinforcement and the carrier for the polymer, there are some more hurdles for us to overcome compared to the likes of using glass fiber, which is more of a refined, more engineered product typically.
Yeah, awesome. Yeah, I think we'll take a couple more. Just let me sift through them. We've got a networking for you, Jack. Are you in touch with my colleagues from Hungary, Budapest University, and Mechlin Company? They are working in a similar topic and are already achieving, I think, similar TRL level with their PLA flax-based PCB boards.
Uh, yes, to Mechlin, we're aware of Mechlin. They are one of our development partners, and that's something that we're also aware of that project as well. PLA tends to be even softer than our products, and there's some limitations with that material. So we're still prioritizing um, polyvinyl alcohol as our choice. But yes, we do lots of work in Hungary.
Awesome. Question about what is the surface roughness variation and how do you ensure its uniformity?
Um, I don't have a number to give against that.
Yeah,
It's a bit difficult to give a consistent number because of the variability of the natural fibers. But again, that's something that I mentioned in my question before, where we are trying to source or potentially develop more engineered weaves. So something we're looking at is looking at the standard weaves used by glass fiber, and replicating that using natural materials like the likes of lyocell, for example, which is, from what we found, the most engineerable material out there in terms of a natural fiber or a cellulose-based product. So um, there is some natural variability with the surface of our material, but I think as you've seen with your testing and your printing, particularly using, I think the flax variant of our product is probably um, nicer to print on than the jute, for example, but it all depends on the complexity of the circuitry and which trace thickness or you're trying to get down to.
yeah,
It all depends on the context really of the design.
yeah, absolutely. Yeah, I think kind of just the last question here is just generally about availability, how to inquire, is it available in my country? Just kind of there's a couple questions like that, so I'll just kind of throw that generally at you. What's the best way to find out where they can get this, where they can start working with it?
Sure. So our product would be available all over the world. We're not quite at mass or continuous production yet, so we're still on a batch production scale. But we're happy to listen to any inquiries, no matter where you're based. And we can look at getting you some material or some PCBs to work on and test. So geography isn't a limitation for us. We're planning on being an international business.
Awesome. Awesome. I did lie. There's one last question that's a great segue. Is anybody from Jiva planning to be at TechBlick Boston next week?
We're not, unfortunately. We're quite swamped with different trade shows at the moment and trying to choose where we go to. So whether it's printed electronics shows or I did a presentation at TechBlick in Berlin last year, so it's one of those shows that we're familiar with. But we were recently in the US at the IPC Apex Expo in Anaheim, and that was our first exposure in North America in general. We've just got back from Taiwan as well, so um, unfortunately, it's difficult to do all of them. We're not a huge team,
For sure. Yeah,
but it's something that we want to improve and overall just be more. Um, we want to improve our attendance at a lot of these shows. So keep your eyes peeled, I would say.
absolutely. I said it's a good segue because we will be at TechBlick Boston next week. So
Okay,
for anybody in the webinar attending and is planning to go to TechBlick, come see us at booth F4. Maybe I'll try and sneak some of our Soluboard printed samples with the team there. So if anybody does want to just get a little bit of hands-on, they can have that there as well. That's probably a good way to get you guys there without having to have you physically there for it, at least in some way. But yeah, Jack, I just want to say a big thank you for joining us today. Yeah, really cool product, exciting future, I think, for it. And yeah, we've been really enjoying playing around with it and getting prints going on it. I've got all of our contact information for both Voltera and Jack here on our last slide. So I'm just going to keep it up as we end for the day. Jack and I will turn our cameras off and mute, but we'll keep the slide up if any of you in the audience just want to copy down emails to get in contact with us. Yeah, and if we missed any of your questions, feel free to follow up via those emails, and yeah, we'll be happy to get in touch with you. And then I believe just logistically, we will send a follow up with the video recording and some of our slide decks via email in the next couple of days. So we'll get that out to you folks as well. So yeah, thanks so much, Jack.
great. Thanks, Nathan. Thank you for having
Yeah,
me.
absolutely. Yeah, and have a great day, everyone.